Alright guys, and ladies of course, in this video we're going to learn how to find the slope of a line. Now the slope is defined as basically how steep a line is from left to right, a straight line specifically, and we always read our graphs of our lines to identify if it's positive, negative, always from left to right. And the rate of change is the speed at which a variable changes at a specific period of time. Okay, so we're talking about something changing as time moves on or as time progresses. Okay, now to find the slope of a line, it says the slope of a non-vertical line passing through 2 points is the ratio of the rise to the run. Okay, so we always read our graphs from left to right, so let's draw in a line in this coordinate plane. Draw our arrowheads, okay, and then put 2 points in, 1, 2. Now we don't know specifically what these points, the coordinates are, so we're going to label them x sub 1, y sub 1, and x sub 2, y sub 2, just to identify that the little numbers here is to identify that this is x number 1, like it's just a label, and this is just the second x, so we know that this point is corresponding to this exact dot. Okay, so then to find the slope, it's going to be measured as the change of y if you take the difference of one y coordinate to the other and divide that by the change of x, which is the difference of the x coordinates, and that'll give you the measurement of your slope. Or the change of y is also set as the rise, and then the change of x is your run. Okay, so we use m to represent the slope of a line. Okay, so we might want to write that down. So this actually means slope. And then to find the actual slope using a formula, the change of y is essentially if you take your y sub 2 and subtract your y sub 1 and put that number over, or write as a ratio of your x sub 2 minus your x sub 1, that'll give you your slope of a line. Okay? Now finding your slope of a line based on 2 points, let's pretend that we don't have a graph for now. Okay, so when you get 2 points and you have to find the slope of a line, make sure you identify what your x sub 1 is, y sub 1, x sub 2, y sub 2. So we're going to label that right now. Okay, so then in order for us to find the slope, we will use m to represent slope instead of writing down slope every single time. And the change of y, which is y sub 2 minus y sub 1, divided by the change of x, which is x sub 2 minus x sub 1, and now we substitute in our values in for our y sub 2, y sub 1, x sub 2, x sub 1. So we're going to have 5 minus 2, divide that by 3 minus negative 1, and if we simplify, we get 3 over 4. So then 3 is going to be our rise from one point, and then we're going to run to that point 4 units. So our slope is 3 over 4. Now with our visual, we always read our graphs from left to right. So we have to go from this point to this point. And we always rise and then we run. When you plot a point, you have to look at your x coordinate first, so you go left or right, and then y coordinates up or down from that movement left or right. But when you find your slope, it's almost like going backwards. So from this point, we have to rise to the even level of this other point. So we're going to rise first about 1, 2, 3 units. So that's positive direction, so we have a plus 3. And now we have to run to that point 1, 2, 3, 4 units. So then our slope is just 3 over 4. Now looking at B, let's do the same thing. Let's cross off our graph for now, but you're going to use it in a second. But just for the sake of learning it, we're going to label our points first. X sub 1, y sub 1, x sub 2, y sub 2, and then write out how we find our slope, y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1, and substitute what we know, negative 2 minus 4 divided by 3 minus 1, simplify, negative 6 divided by 2, or negative 6 over 2, and reduce it to negative 3, which is our rise, and our run is going to be positive 1. So our slope is negative 3 over 1. Now if we had our graph always reading from left to right, this graph is slightly different since we're going from left to right, we're actually going down, so it's a negative. Hence our slope is actually negative versus the positive we have over here, where the graph is increasing from left to right. So then going from this point, which is C at 1, 4, we have to actually go down all the way to the same level as the second point, which is at 6 units down. So that's why we have a negative 6. Now we have to run to that point 2 units to the right, and then to find our slope, it's our ratio of our rise to our run, so negative 6 to 2. We simplify our ratio, divide both sides by 2, and you get negative 3 over 1. Okay, so if you look at with our visual, it matches exactly what we have for when we substitute our values into our formula. Alright, so example 2 is a little bit different. We'll take a look at each case specifically. Let's cross off our graph and actually label our points x sub 1, y sub 1, x sub 2, y sub 2. So then using our slope, we know that we're going to take our y sub 2 minus y sub 1, so 5 minus 5 divided by negative 4 minus 2, simplifies 0 divided by negative 6, so we have a slope of 0. Okay? So if you look at our graph, we always define our slope as the rise over our run. Well, to get from one point to the other, do we have to rise any units up or down? Absolutely not. So that our rise would be 0. But we have to still run. So we still have to run 1, 2, 3, 4, 5, 6. So then our rise would be 0. Our run would be 6. So then our slope would be just 0 over 6, which is just 0. I should have wrote down a 6 right here, but if you mathematically calculate that out, it's going to be calculated out to 0. Okay? Alright, let's look at B. So now we have 2 points again. We're going to label them x sub 1, y sub 1, x sub 2, y sub 2. And then to calculate our slope, with m equals 3 minus negative 2 over 4 minus 4. Simplify further, 3 plus 2 ends up being 5 divided by 0. And because you can never divide by 0, it doesn't make sense. We have a graph that's with a slope that's undefined. Okay? So then, looking at our points, going from one to the other, we rise or fall down 1, 2, 3, 4, 5, but don't run any, so our rise would be 5, or negative 5, and then our run would be 0. So since you can't actually divide by 0, our slope is going to be considered undefined. Alright, in example 3 we have to find the rate of change. So the table shows the cost of gallons, or the cost of a gallon of gas for a number of days. Find the rate of change with respect to time. So we have our chart where days is going days 1, day 2, day 1, day 3, day 5, going up by 2, and we know that the price seems to be going up. So if we were to actually graph it just to take a look at what it looks like, we have our x values, which would represent our number of days, so it's our time. Okay, so we have 1, 2, 3, 4, 5, and then on the y-axis we'll have our price per gallon in money, and label our tick marks at 25 cents, 50 cents, 75 cents, go up by 25 apiece. Okay, so then just to get an idea, it's going to be very difficult to graph each specific point. If these are going to represent our x coordinates and then our y coordinates would be the price. On day 1, 2, 3, or 4, on day 1 we have a price of $1.99 per gallon. On day 3 we have about a price of $2.10 or 9 cents specifically. And then on day 5 we have the price of $2.19. If you look at from one point to the other, our line is steadily increasing, not by much, but about by 10 cents. Okay? So then if it's asking for the rate of change, we're trying to figure out, well, how's the price increasing from one day to the other? Okay? So if we have specific points, that this point is going to be 1, 1.99, the second point is 3, 2.09, and on day 5 the price was $2.19. So the rate of change is another way of asking, well, what's the slope? Okay? So the slope and the rate of change are essentially the same thing. Now we just have specific units that are tied to the rise and tied to the run. So to find our rate of change, y sub 2 minus y sub 1, pick any 2 points on that line. So I just pick these 2 right here, and then you have your y sub 2, 2.19, minus your y sub 1, 2.09, divided by your 5 minus 3. You simplify further, you get 10 over 2 days, so 10 cents in 2 days. And then specifically for the rate of change, you want it per day. Okay, so we know it's 10 cents per day, but we can reduce this even further, and it's about 5 cents a day. So our rate of change is 5 cents per 1 day. Alright guys, thanks for watching. Hopefully you have a better understanding on how to actually calculate the slope of a line when you're given 2 coordinates or even when you're given a graph, and how you can connect the slope, the concept of it, with the rate of change.